Hey everybody, we're gonna get going on chapter 11 now. Hopefully it shouldn't give you too much trouble. All we're doing is we're adding a third variable, okay? We're going from 2 space to 3 space. So, as we look at our notes, we notice a couple things change right off the bat. We have this z-axis, okay? That's the z positive, that's the z negative that goes up and down in our graph now. Our y-axis goes side to side, and our x goes forward to back, okay? It's like that, our positives and our negatives. The big thing with the x one is always remember the positives are coming towards you, okay? So let's look at equations of planes. All right, if we're looking at the xy plane, what we're saying is our z equals 0. Okay, so if you're describing a point, it's going to be x, your y, and then a 0 for your z. Okay, same thing goes for the yz plane. That just means your x is 0. And so forth with the xz or y0. All right, all we're going to do is plug 0 in for those points. Okay, so that's just giving you the general example of what your points should look like. So an example over here, if you guys look at this graph to the right, 0.425, what you're going to do is start here at the origin. Okay, our first point is a positive 4, so we're going to come out 4. All right, then our next one's a positive 2. We're going to go positive y2. And look, you're going to draw your lines parallel to the axis. I'm parallel to that y-axis over 2. And the final thing is up 5, positive 5. Go up 5 on the z, and you should be there. Okay? That's what we're going to look for whenever you're asked to graph a point. We want to see you start at the origin, draw the path, and then draw that final point. Okay? If it helps you, sometimes a good check is doing these dotted lines, completing the parallelogram. All right? Because those 3 points, if you fill in all their dimensions, it makes a parallelogram. Okay, I think I got them all. Yeah, that one's good. Okay, so now let's look at the equations of the axis. Okay, so if we're looking at the x-axis, that just means our y equals 0 and our z equals 0. Okay, so if we're just looking at the axis, it's going to give us our x, 0, 0. Okay, the y-axis is going to look similar. Your x is going to equal 0, your z is going to equal 0. Okay, that's going to give you 0, y, 0. All right, for z, x is going to equal 0. Y is going to equal 0. So it's going to give you 0, 0, z. Okay, this is just some generality so you understand what these words mean when you're being asked in questions. All right, again, plotting points. So here's another example. We have 2, 3, 4. Okay, so we're going to start at the origin. We're going to come out 2. We're going to go over 3. And then we're going to go up 4. About right there. Okay? And that's all you got to do to plot that point. To plot this other point, we got negative 2, 1, 4. Okay, so here we got to draw the axes. So let's just draw one here. Let's draw one here. It's nice when you have this special graphing paper that you can make those lines nice and easy. They got all the lines drawn on there for you. Okay, that's 3-dimensional graphing paper right there. So again, we're going to start at the origin. We're going to go up 2. We're going to go over 1, our y-axis, and we're going to go negative 4 down on our z. Okay, and that's going to get us right there. All right, if we filled this one in, let me just complete this parallelogram for you. That it's going to be that. Oops, not like that. I messed up. Like that. Something that looks like that. Okay? But remember, all you have to do is draw the path of the point. Okay, this is our x negative, this is our y positive, x positive, z negative, z positive. Okay, if it helps, label those axes every time. Make sure you're graphing it the right way. Okay, moving on down to 3, we're going to look at equations of planes. All right, I'm not going to lie, drawing the plane is very, very hard, but I'll try to show you a way to do it. It's kind of like trying to draw a piece of paper. It's tough. How do you draw a piece of paper and show those dimensions? So even though a piece of paper technically has 3 dimensions, we think about it as having like 2 as an example of drawing. Okay, so graph the set of points M of all points x, y, and z such that y equals 4. So what are they asking us? They're saying we're graphing the whole plane at point y. So you think about it, can be any x, our y has to be at point 4, and it can be any z point. Okay, so it's a plane at y equals 4. All right, so what that looks like, I'm going to do my best here. You're going to come out 1, 2, 3, 4. Think about trying to draw a piece of paper. So the bottom of your paper is parallel to that x-axis because it's all your x's. And then you have kind of another piece of it that goes parallel to the z. Right, it goes all the way down, all the way over. So it just looks like this piece of paper that goes across at 4. All right, that just means your x, it's pretty much saying your y is always 4 and your x and z can be anything else. That's what they're looking for in a plane. All right, moving on down to 4. Graph the set of points n of all points x, y, z such that 3y plus 4z equals 12. Okay, what they're looking for here is we got to make a plane parallel to the axis. Okay, graph a set of points n of all points such that 3y equals 4. Okay, so first thing we're going to say is we're going to draw out these points. X, 4, and our x, 0, 3. Okay, we're putting those in there because we know our zeros have to be at those points. We have our equations that we get from that original, our 3y equals 12, or 4z equals 12. Okay, and from here we can plot points. We know that the x, if you make a table, your x is always going to be the same thing. It can be anything. So your x point can be anything. Okay, your y and your z points. You start plugging in the tables. When you plug in a 0 for z, you get a 4 for y. Okay, when you plug in a 0 for y, you get a 3 for your z. All right, that's how we kind of get those equations up there. And then you can just plug in another number, plug in a 2, and you get 3/2. Okay, so the first thing you're going to want to do is we're going to graph that line. We're going to graph that 3y, 4z line. And with our points, our 0, 3 and our 0, 4, and we know it can be any x. So it can be anything along that x axis, that parallel x-axis. So just knowing these 2 points from our equations are 0, 3 and 4, 0, you almost have, think of it as like a line that goes right here. Because that graph, that 3y plus 4z equals 12 is just a straight line. But it's the plane that lays on that line and is parallel to that x-axis. So you can kind of think of it as a piece of wood or something laying up against a wall. Okay, you got a plane like that. It's really tough to draw, but if you think about it, if you can think about it in 3 space, there's a line, a string that's held from 3 inches up on the wall, and then it's tied to that point on the wall, and then you have a string. The other part is tied to 4 inches across on the floor, so you have that tension of the string, and then you just lay a piece of paper on top of it, so it's like a plane resting against the wall. Okay, it's tough. I suggest that you guys pop out Desmos or something and start looking at those graphs. If you ever need help looking at 3D graphs, start plugging them into Desmos. It's a great tool. All right, so now we're going to use the distance formula, and we're just going to write that in 3 space. Okay, it doesn't get too much it doesn't get more complicated at all, actually. We're just adding the third variable. All right, we're just adding that z in there and squaring it. So that just means the distance from the origin, that's what you get for the distance between 2 points. Just having our 2 points, or x2 minus x1. Oh, it's the square root of all this too. Plus y2 minus y1 squared plus z1 minus z2 minus z1 squared. Okay, so our distance between 2 points and then our distance from the origin. So find the distance between 5, or finding the distance between A and B. We're going to plug those into our distance formula. The way I think about it, I always just use the second one first. Use that B. Use that B as the second one. So what you get when you do this, your D equals 3 minus negative 1 squared plus 4 minus 5 squared plus 2 minus 0 squared. Okay. Continue to simplify. Our 4 squared plus negative 1 squared plus 2 squared. Alright, leaves us with 16 plus 1 plus 4. So leaves us with the square root of 21. Okay, not too bad. You want to look at it in graphing form. Okay, we got our z or y or x. Alright, from A to B. Let's see, the first point is going to be 3, 4, 2. So that's 1, 2, 3. About right there. And the other one, what was that? That was A. B will be green. That's negative 1, 5, negative 1, 5, 0. So just right there. So we have this line, we're measuring that distance between them. That's what our D is. Okay. Moving on to the equation of a sphere. Equation of a sphere. All right, what we're looking at, this might be familiar to you guys. It's just an x point minus an a, or x minus a squared, y minus b squared, z minus c squared. Big thing to remember, your a, b, and c is the center point of your sphere. The r is the radius. Okay, not r squared, so you would say the square root of that number, okay, is the radius. So let's hop into it. 6. A sphere has points A 8, negative 2, 3, and B 4, 0, 7 as endpoints of the diameter. Okay, hopefully we know what the diameter is. That's the line that goes that cuts the circle in half. Okay, so if you think about it here, you kind of have a sphere looking thing like that. We have points A, we have points B, and then we have a line, the diameter that goes there, and we'll just say our point C is the center. Okay, so that's the visual we're looking at. Find the center C and the radius R. So we could think about it in a couple ways. The center is the midpoint of our diameter, right? It's halfway between A and B. So what we want to do, the center equals our midpoint. We just have to do the midpoint formula. So our center is going to equal our 2 points. We're going to subtract them, and we're going to add them, and we're going to divide them by 2. Okay, so that's going to be your x point. It's going to be your y point. Going to be your z point. Okay, when you solve those all out, your C is going to be, your center is going to be 6, negative 1, 5. All right, so we found the center. Now the radius. Radius is the center to B or A. So we'll just say to B for this one, right? The radius is from the center out to one of those side points. So all we got to do is our point-to-point distance theorem. Okay, simplify that out. Get square root 2 squared plus negative 1 squared plus 2 squared. Simplify it down, you just get square root of 9 or 3. Okay? So we got a radius of 3, found our center point at 6, negative 1, 5. Question answered. Okay, now we want to find the equation for the sphere. So remember, looking up here, A, B, and C is our center point. That's all we got to plug in, and we know we have a radius of 3. Okay, so if we're going to plug that in, okay, and from here, let's expand it out. Okay, let's get this to its simplest form. So we're going to have x squared minus 12x plus 36 plus y squared plus 2y plus 1 plus z squared minus 10z plus 25 equals 9. Okay, right, our 9, we got that 9 from our radius squared. Okay, so finally, just organize this by degree. You're going to get x squared plus y squared plus z squared minus 12x minus 2y minus 10z and plus 53 equals 0. Okay, that should be your final answer right there. All right, make sure you simplify it all the way down. Keep your work neat, keep it organized. It'll help you. All right, last one for today's notes. We're looking at 7. Find the center and the radius of the sphere with this equation. So now they're giving us the equation. We got to go backwards. All right, so this is going to hopefully sound familiar. Again, we're going to have to force this one to work. So let's set this up so we want to go backwards. So we're going from like this step to that step. All right, so we're going to have our x squared. And then I'll put these in parentheses so it hopefully helps you visualize it better. We're going to have our x squared plus 6x plus a blank. Okay, plus, let's change up the color. Our y squared plus our 5y plus a blank. Plus our z squared plus 2z plus a blank equals 4. Okay, so all I did, I moved that 4 over there, I reorganized these, and I put a blank in, because what we want to do, we now want to make the leap from here to this line. So we want to have it in our perfect square, so we got to force it to work. All right, so if I'm looking at these, remember, it's half of your middle term, right? The way I think about it is it's half of this term and then square it. All right, because here, I mean, I can just draw the next line. The next line, we know what we want it to make it look like. We already know the next line because we're going to force it to work. All right, we know it's going to be one of these. Okay, so we divide this by 2. That's going to give us this term down here, and then we square it to get the one up here, the 9. Okay, same thing with the y. You divide that by 2, gives you 5/2. All right, and then you square it. It's going to give you 25/4. All right, I'm just going to keep that like the fraction there. All right, the next one, you take half of that 2, you get -1. You square it, you get a +1. Okay, the big thing to remember, when you start adding all these terms in, the 9, the 25/4, and the 1, you have to add them to the other side too. We have to balance it. So +9, plus 25/4, plus 1. Okay, it's going to give us 81/4 over here. So now from here, we can look at it. We know that our center, we're going to use our A, B, and C. Our center is at -3, -5/2, and 1. Okay, our radius is the square root of our 81/4, which equals 9/2. Okay?